So next we need to talk about rocks and minerals. So a mineral is a naturally occurring inorganic solid element or compound with a definite chemical composition and a regular internal crystal structure. A rock is a solid cohesive aggregate of one or more minerals. So each rock type has a characteristic mixture of minerals, grain sizes, and ways in which the grains are mixed and held together. The rock cycle is the cycle of creation, destruction, and metamorphosis. You probably learned this sometime in grade school, but we have three major types of rocks, and we're going to go through all three of these: igneous, sedimentary, and metamorphic. And you will need to know the three kinds of rocks. So this shows how rocks are transformed between the three different forms. So igneous rocks are created by volcanoes. And sedimentary rocks are created when layers of sediment are compressed together. But you can see here there's very low temperature and pressure. Because igneous rocks are created in volcanoes, they have very high temperature and pressure. And we can see sedimentary rocks can form into the other two types of rocks. Sedimentary rocks become igneous rocks when there's melting and crystallization, and they can become metamorphic rocks when there's heat and pressure, deformation, and recrystallization. We see that metamorphic rocks can become igneous rocks when there's melting and crystallization. Igneous rocks can become metamorphic rocks if there's heat and pressure, deformation, and recrystallization. And both igneous rocks and metamorphic rocks can become sedimentary rocks if they're weathered, if they're basically reduced to sand and then piled on top of each other with low temperature and pressure, they can become a sedimentary rock. Okay, so igneous rocks. These are the most common type of rock in the Earth's crust. They're basically solidified magma extruded onto the surface from volcanic vents. If there is quick cooling, you get these fine-grained rocks, and if you have slow cooling, you get more coarse-grained rocks. Here are some examples of some igneous rocks. So you've probably heard of basalt, granite, obsidian, maybe pumice. These are all examples of igneous rocks. Metamorphic rocks are when pre-existing rocks are modified by heat, pressure, and chemical agents. And chemical reactions can alter both the composition and structure of rocks as they are metamorphosed. So metamorphosed meaning changed into something else. So examples of some metamorphic rocks are marble, which is created from limestone, quartzite, which is created from sandstone, and slate, which is created from mudstone and shale. So that's how rocks are formed. Rocks are broken down through weathering. So we have two types of weathering here. We have mechanical weathering, which is exactly what it sounds like. It's the physical breakup of rocks into smaller particles without a change in the chemical composition. So this is when rocks are broken apart into tiny parts, and that's mechanical weathering. We also have chemical weathering, and so this is the selective removal or alteration of specific components that leads to weakening and disintegration of rocks. So we get processes like oxidation and hydrolysis when we're talking about chemical weathering. Another important aspect to this is sedimentation. So after the weathering occurs, the deposition of particles of rock transported by wind, water, ice, and gravity till they come to rest in a new location, that's called sedimentation. So layering of little bits of rock, sediment, over time is sedimentation. So this just shows weathering and sedimentation. We see up here, we have weathering on the mountains. We're breaking down rocks both physically and chemically. Erosion carries these particles produced by weathering away. They could be transported in water or glaciers, or wind might move them as like bits of sand. And when they're transported, they're going down in elevation. And then we have deposition, which can occur when particles settle out or dissolved minerals precipitate. And so we get deposition or sedimentation in lakes, in streams. In streams, often sediment eventually gets carried to deltas, or eventually a lot of sediment also is deposited in the ocean. We get burial, where layers of sediment accumulate and compact previous layers. So we can see here the different layers through time are getting buried. And then we get diagenesis, which involves pressure, heat, and chemical reactions that lithifies the sediment to make it into sedimentary rocks. So sedimentary rocks are deposited materials that remain in place long enough or covered with enough material for compaction that may again become rock. So examples are sandstone, shale, and limestone. The rock type indicates the environmental setting. It also can be formed from crystals that precipitate out of or grow from a solution, like halite comes from sodium chloride. So this shows some of the examples. Clay over time becomes shale, silt over time becomes siltstone, sand over time becomes sandstone, gravel can become a conglomerate. So depositional environments. So where does sediment accumulate over time? Usually low-lying areas. So we're not going to have sediment accumulating on top of mountains. Wind and water are going to bring them down to the lower levels. Sediment usually accumulates in aquatic habitats. So in lakes we see sedimentation. Over time, lakes fill up with sediment. Lakes have a lifespan because they are formed by a number of different processes, but over time, wind and water carrying sediment into them fill them up with sediment, and they eventually become a wetland that's very shallow, or they can eventually become a terrestrial habitat. We see sedimentation being deposited in deltas. Streams and rivers carry lots of sediment. So the Mississippi River carries tons of sediment, and it used to flood all the time before we constrained the Mississippi River, and it would deposit sediment in Louisiana, and so we would gain land every year when the Mississippi River would flood. It would leave feet of sediment in the floodplain around the Mississippi River. The Army Corps of Engineers has constrained the Mississippi River so it can't flood anymore, so we don't have that deposition anymore. We send all that sediment out into the Gulf of Mexico, into deep water, but some of the work that people are doing to restore coastal wetlands in Louisiana involves diverting the sediment from the Mississippi River to shallower areas so that we can build up land again to form new coastal wetlands. So this shows North America during the Cretaceous about 100 million years ago, and we can see that a lot of North America was underwater. And so these are areas where sediment was being deposited, and so we have a lot of areas now that are karst regions that have a lot of limestone that were, especially in Florida and some of these areas, because sedimentation was occurring and sedimentary rocks were eventually being formed. So sedimentary rocks can also be shaped by erosion, which we can see very dramatically in some places in North America. So an example is Grand Canyon National Park, where we can see all these layers that used to be built up, but erosion has carved out the Grand Canyon over long periods of time. Another example is Bryce Canyon National Park, which has similar kind of layering to Grand Canyon, but the erosion has occurred a little bit differently to make this kind of spectacular scenery. I also want to point out that geomorphology is the study of the processes that shape the Earth's surface and the structures they create. So studying these things, would be geomorphology.